Hey everybody, so this is Professor Belcher, and we're going to try and finish Chapter 1 PowerPoint today. It's a lot of information, and I know that some of it doesn't seem like it pertains to sports nutrition, but it really does, because it's going to talk about how we take the nutrition, the food that we eat, and all those nutrients, and how it gets converted into our body to be used for energy so we can jump, run, and play the sports that we love to play. So what we're going to look at is the last portion of PowerPoint for Chapter 1 and how energy is stored in the body. So we have the 3 macronutrients, and we've talked a lot about macronutrients, so protein, carbohydrates, and fats. All of these macronutrients get broken down into, as they enter the body, they get broken down so that they can go into what we call the Krebs cycle. Now, I want you to understand that we're not going to go in-depthly into the Krebs cycle. We're not going to go in-depthly into the energy systems. I'm just going to give you a real big basis of it so you have a working knowledge, but you can spend even years studying the Krebs cycle. Krebs cycle kind of also goes into exercise physiology and how the body uses different systems to create energy. So one thing that we need to understand is that we have what's called ATP, so adenosine triphosphate. Then you have phosphocreatine, and then you have the macronutrients. So this is how your energy is stored. Now, ATP is also, it can also be stored in ADP, and so we have to go through this breakdown to create ATP and ADP. So we're going to look at protein, carbohydrates, and fat. When we look at those, we're going to look protein is then going to be broken down into amino acids. So there are amino acids that it gets broken down as you go through the digestive system, and the body uses the enzymes to take care of the body, so to break down the protein that you have now ingested. So this protein gets broken down into what we call amino acids. Then this goes into CoA, and then that moves into what we call the Krebs cycle. So there is a process for it to get there. Now, carbohydrate gets broken down right away into what we call glucose. So carbohydrate is broken down into glucose, then it goes into the acetyl-CoA, and then into the Krebs cycle. Now, ATP, as it's broken into glucose, ATP is actually created right after it's broken into glucose. And so, carbohydrates actually broken, it's a lot faster. That's why when you maybe are struggling, like you have a headache or your just body is needing something right away, that's usually when you go and get some type of carbohydrate. You don't want to take a protein or a fat because it takes it longer to actually digest. So that's why we look at carbohydrates: quick, easy to digest. And that would be something as we move on. What do you use when you're in training, when it's a longer race, or any of those types of things? We have to look at the carbohydrates that we need. So I want to make this clear. Fats, carbohydrates, and protein, they're good for you, okay? They're good for you in all spectrums. We need all 3 macronutrients, and there is a balance to it. So you can't be extreme on either end, because you do lose some other areas like micronutrients that you might get from certain carbohydrates or certain fats or certain proteins. So just be aware of that. Then the last thing is fat is also broken into fatty acids that goes into acetyl-CoA, and again, everything goes into the Krebs cycle. So the Krebs cycle is a major proponent of developing ATP. ATP allows for fast twitch muscle fibers to fire right away. And there's also this portion of like the musculoskeletal system of we have to have some energy to make the muscles move, electrical. So there's a lot that goes into it, and that's exercise physiology, and I would recommend taking that. We're just touching base on this because of how sports nutrition, how your nutrition plays into the energy that you're going to have. So, a couple things. You have ATP, we talked about, ADP, PCR, phosphocreatine. So, now we have energy systems. And so what is the human energy system? So there's a couple different ones, and we're going to look at it from a running perspective because I think this is the most easiest way to understand it. And it breaks it down because you have sports that are like basketball or soccer or football, and those are definitely different, and that some of them can be combination of energy systems. But we're going to look at running because it's going to be very allows us to look succinct in understanding the energy system. So we have what we call anaerobic power. So there's anaerobic power, and anaerobic power is where we're looking at short distance, like quick, fast, as fast as you can. And this would be a runner that runs between the 60 meters and 200 meters. So they're not running more than 200 meters. They would have to train another energy system if they're going to run a 400. So this only lasts 6 to 20 seconds, and they are giving everything. And so this would be what we call the ATP PCR. Those are the energy sources that they're getting this from. Now, that's anaerobic power. Anaerobic means without oxygen, and power is as quick. Power is we want to cover as much distance in as short amount of time as possible. So those are some things to be aware of. Now, then we're going to look at anaerobic capacity. So anaerobic capacity is running a 400 to an 800. So you're using more oxygen. How much can you extend that distance? And so anaerobic capacity. And so what we're looking at is, so it's not just quick and as fast as possible. There is a little bit of energy that's used over a longer time frame. So that's anaerobic capacity. Then we have aerobic power. So this is somebody that can run the 5,000 meters. This is somebody that's 12 to 26 seconds. So they're out running a quick 3 miles. That's anaerobic power. So they're trying to go as fast as they can over a distance, but not a long distance like you're running a marathon or a 10K or anything like that. That would be aerobic capacity. So you have anaerobic power, anaerobic capacity, aerobic power, and aerobic capacity. So those are your 4 categories of human energy systems. And so you can kind of see the difference of what that looks like. And everybody's going to train. So one thing is how you're training is what you're training a certain energy system to be used. So if your sport calls you to be quick over a very short amount of time, then you should be training aerobic power or anaerobic power, If you're a longer period, but you're also trying to gain oxygen, that's aerobic power. So understand. So I think the easiest way is understanding like a sprinter versus a miler. 2 different energy systems being used. Both are going extremely fast if you're at the Olympic level, or even at any type of level that if you're at a higher time frame, higher level. So just understand that those are some energy systems that we use within the body. Now, there's an oxygen energy system. So we're using anaerobic and aerobic. So those deal with, aerobic is dealing with oxygen is being used and oxygen is being oxidized so that it can be used for energy. Anaerobic, there is no oxygen being used. It would take too long, and we're trying to create as much power or as much capacity as possible in that short amount of time. But when we're looking at the energy system with oxygen, we have aerobic glycolysis, and that is the oxidation of glycogen or glucose. So we're breaking down, we're using glucose to create energy. So oxygen is being used to break down glucose or glycogen. So that would be your carbohydrates. Aerobic lipolysis is the oxidation of fatty acids. So this is the breakdown using oxygen to break down fatty acids or fat. That's what's going on in that energy source. And then there's aerobic proteolysis, and this is limited energy. So this is the oxidation of glucogenic or ketogenic amino acids. So this is going to be ketogenic amino acids. This is going to look at protein and breaking down Protein. So we have three different energy systems where oxygen can be used to break down the different carbohydrates. So you have glucose, which is carbohydrates, or excuse me, the macronutrients. So you have glucose being broken down, which is a carbohydrate. Then you have fatty acids, which is also, that's going to be fat. And then you have ketogenic amino acids. So amino acids is going to be your protein. So those are things to be aware of that we have to understand. Now, necessary for operation. We talked about one of the nutrients that doesn't really have a category where you're going to get minerals or vitamins from, but that is water. Water is a huge source of nutrition, even though it doesn't have a nutritional value. It actually helps your body function. So you need water. And you're going to get water through eating an apple. You're going to get water from having your coffee, from your other drinks. But one thing to be aware of is that water is still, it's not fully just water that's going to go directly into supporting your body as a whole. So sometimes some of you probably have had a issue where you've been dehydrated. And that's because you haven't gotten enough water into your system. So just be aware of that. Now, what is metabolism? And this is a big question that, can I speed up my metabolism? Can I slow my metabolism down? Now, this goes along with a lot of other things. So your like expenditure, how much you expend on a day. Some people would say, well, I just have a fast metabolism. I take in food, I digest it. Everybody's going to digest differently, yes. But it depends on what the toxicity level of certain things. So we're looking at labels, we're looking at processed foods, we're looking at all of those types of things. What are you eating? Is there certain foods that are better for you? Certain foods that are not? I've talked about myself. I shouldn't be eating sourdough bread. It has an effect on me. So that's a toxicity item. So if that's something that I can't have, then my body's metabolism is going to slow down. Something to be aware of. Also, how much body fat do you have? How much weight, muscle mass do you have? Those are things that we have to be aware of. And everybody also has different body types. So BMR is the resting post-absorbent. So right after this is like when you're sleeping or when you're tired is when your metabolism is at its lowest. So we have to be aware. If we're tired and we're starting to eat, it is going to be slower. So it's dependent on when you eat. It's not that your metabolism actually goes in a waves throughout the day. And so when you're supposed to be sleeping, your metabolism is going to be slower because you're supposed to be sleeping. And so, as college students, most of you like to stay up really late, or you're waiting till the last minute to maybe get your stuff done, and then you eat within that time frame because you're stressed out about it. And so then you could see that maybe your metabolism starts to slow down. Just be aware of like timing of food. And we're going to talk later on as we further our discussion in sports nutrition about timing and what rest does and all of those different things. So just be aware that you're going to learn that. But your BMR is resting basal metabolic rate. Now, you have your basal energy expenditure, so your BEE, and this is how much you expenditure over 24 hours, like how much energy you expenditure over 24 hours. And everybody's going to be different. So how much you move, how much of your body weight, what goes all on into that. So just be aware, resting metabolic rate is small amounts due to prior activity. So BMR plus small amounts due to prior activity. When you're resting, so if I went and worked out, then I'm going to go, I got to stretch in, and then I'm just going to sit, maybe read. While I'm resting, my metabolic rate is actually higher than my BMR, my basal metabolic rate. So because I've added exercise into that, my metabolism has increased because my body is still adjusting. So that's just where the resting metabolic rate comes into play. And then resting energy expenditure is, this is over like over a 24-hour period that you're going